Today's lesson over half-life and natural logs, it's really decay, all right? We've done exponential growth before, and that's when your base number is greater than 1. So exponential growth, that one is no bueno. Let's do exponential growth. The base number is greater than 1. Greater than 1. But exponential decay, the base number is less than 1, but greater than 0. Remember, you can't have a negative, and you can't have a base that is 0 either. So, this is what we're going to be working with. We are going to be working with decay. Half-life is something that some of y'all may have used it in a science class. If any of y'all taken the forensics class, or are you in forensics? I know I did first period. Or if you've seen some Law and Order shows and whatnot, they talk about how long it takes for something for its elements to go away, to disappear, to be inactive. A lot of this is done in radioactivity. For if you think about the nuclear bombs, how long will it take for all of those elements to dissipate so that it's livable? Did y'all ever see the 100 series on Netflix? Mm-hmm. Okay, where they had to escape from Earth and then wait until everything got safe so they can go back to Earth, but they had to wait for all the nuclear stuff to be gone and everything. That's what this is all about. Okay, so when we say half-life, that means how long it takes for half of the elements to dissipate, okay? And depending upon what it's talking about, I mean, it could be minutes, it could be thousands of years, it could be a very long time, but it's like a half-life is like a marking in time. All right, our formula that we use, it's pretty heinous looking right here, but I'm going to explain it to you, how it works. And you don't have to memorize this. You will be given this formula. What you will have to do is be able to manipulate the formula to solve for different for different variables. All right. When you are talking about a substance, N sub 0 is what you begin with. This is your beginning amount. It's what you start with. And N of T, this is what remains. And a lot of times you may not be given an actual number as far as so many milligrams, so many pounds, so many whatever the case may be. It may be a percentage. And then you'll use that percent in the formula, but you use it as a form of a decimal. All right? Then you've got H. And H actually is the number of years or time for the half-life. T is the time frame. How much time has passed. So if your half-life is measured in days, then your time will be in days. If your half-life is measured in years, then your time will be in years. So we put them in the same measurement. All right, you've got the natural log of 2. We'll explain what that happens with that here in a second. You've got E as your base number, and then did you notice that this is a negative exponent? So this whole expression right here is an exponent, and you've got it's negative. So what I want to explain is that your base of E, this represents continuous change. All right, it's not in stages, it's not in steps, it's continual. And then the negative exponent represents the reciprocal of e. Okay, now, when we say the reciprocal of e, do y'all remember what the value of e is? Approximately, can you start it off? It's 2.7183, something like that. Yeah, e is approximately 2.7183. All right? Now, if we write the reciprocal, then that would be 1 over e. So that means our denominator would be bigger than our numerator. So that means I have a fraction. So now, and it's going to be less than 1. And any time our base number is less than 1, it's going to represent decay. So even though our base is 2.7183, we've got the negative exponent that says, okay, it's really the reciprocal of that. So it's really a fraction. It's really a number less than 1. All right. So just make sure you note that this is making the base less than 1. All right. Now, using this formula, what we're going to do is explain why this represents half-life. Okay? So what we have to do is we have to say, okay, we're going to set the time equal to h. So time, if t time is equal to h, the half-life, then in the formula, oops, totally misspelled formula, they factor out. What I'm saying is, if say t was 10 years, and the half-life was 10 years, the amount of time that passed is the half-life, those two numbers would factor out. They'd reduce out. Does that make sense? Just a fraction. Okay. Now, if that's the case, then what remains is equal to what we started with times e to the power of negative t natural log of 2 divided by h, and I want you to note that the time and half-life cancel. The time and half-life cancel because they are the same number. All right. Now, let's rewrite that. Oh, why did I put equals twice? I'm stuttering. Now what we have left is e to the negative natural log of 2 power. Now, if my base is e and I've raised it to the power of a natural log, that's the same thing as log base e, because they're inverses, right? Well, I can kind of eliminate this, my base, but I have to get rid of this negative coefficient first. So to get rid of that negative coefficient, what can I do? How can I rewrite this expression right here? Or just up here in the exponent, just this part right here. What can I do with that? I can move it into the exponent. Yes, I can write it as the natural log of 2 to the negative 1. And if we've got the natural log of 2 to the negative 1 power, now you can see that your base and your natural log undo each other, cancel each other out. So what you're left with is what we started with times 2 to the negative 1 power. Well, what is 2 to the negative 1 power? How can we express that so we don't have a negative exponent? 1/2. That's right. So in sub-zero, what we start with times 1/2 is equal to what remains. 1/2 of what we started with is equal to what remains. That is just expressing the half-life. So this formula is designed to find what remains after a certain period of time. And if your time is equal to your half-life, you have half of your substance remaining. Okay? So that's how, I just wanted to show you how this works. Now, this is using natural logs. You can do half-life without using natural logs. You can use regular logs. Do you know what your base would be? It'd be 1/2 to show that you've got 1/2. We'll talk about that later. That's going to come up later on in next week. All right. So now then, the next thing we're going to do is practice manipulating this formula. Because what's going to happen is you're going to be given all of this different pieces of information, but you're going to be missing one piece. And if that one piece happens to be half-life or time, those are in our exponent, and we're going to have to draw that out of the exponent. So we're going to have to manipulate this formula to get that out of there. So in order to do that, what we're going to start with is practice manipulating the formula for time. So we're going to solve our formula for time. So to start off with, let's go ahead and write our formula down. Make sure you remember that this whole thing is an exponent right here. This whole thing is an exponent. Okay, and before I can eliminate, I'm going to have to natural log to get rid of the base e, to bring everything down. But before I can do that, I've got this coefficient in front. What should I do to get rid of this coefficient? Think of just any number. Think if this was 2x. What would you do to get rid of the 2? Divide. That's all we do. We divide both sides. So we've got n of t divided by n sub 0. And that's equal to e to the negative t natural log of 2 over h. Okay. Now, what could be our next step? Our goal is to get t out of the exponent. What could we do to get rid of our base of e? Not divide. Did you say divide? How do we, what's the inverse of e? Natural log. So we're not going to log both sides, we're going to natural log both sides. So I'm going to write that in red here to show natural log. So now what we have is the natural log of n of t divided by n sub 0 equals, your e is canceled, your base e is canceled, so you have a negative t times the natural log of 2 divided by h. Okay. Algebra. We're still whittling this down, trying to get t by itself. What would be your next step? Multiply both sides by h. There you go. So number 4, you would end up with h, and I'm going to put a bracket just because I'm trying to separate stuff. You don't have to. Times the natural log of n of t divided by n sub 0, and that's equal to negative t natural log of 2. Now, let's try to get all of this t all by itself in this next step. What would I have to do to get rid of the negative and the natural log of 2? Divide by negative natural log of 2. There you go. So if we divide, and I'll write that down, divide by negative natural log of 2 on both sides, we end up with a negative h times the natural log of n of t divided by n sub 0 over the natural log of 2. And now we have manipulated this formula to solve for t. Okay. Now, what we're going to do in problem number 3 is we're going to use this manipulated formula to find out how old an artifact is. Okay? How much time has gone by. The half-life of the substance carbon-14 is 5,700 years. So that means after 5,700 years, only half of it has dissipated. Okay, so it's got a long life. All right, and the amount of carbon left that we're looking at right now is 85% of the original amount. The original amount, n sub 0. How old is the artifact? What I want to point out is they are giving us what's left and what we started with, but they're giving it to us in the form of a percent. If what remains is 85%, that's 0.85 of what we started with, which was 100% or 1. Doesn't even matter what the actual measurement amount was. All that matters is we know how much is left over, or how much remains, or how much was used. If 85% is left over, how much dissipated? 15%. 15% is gone. Now, how many years does it take for 50% of it to dissipate? Think about my question. How many years does it take for 50% of the carbon-14 to decay? 50% is half of it, right? What's its half-life? 5,700 years. So 5,700 years for 50% of it to remain. Okay? I'm just trying to get y'all to think in terms of what we're working with, because when you first deal with this type of problem, it feels very foreign. But after you've done a few, then it starts to make a little bit more sense. All right. So what I want you to do is I want you to show that your H value, your half-life, is 5,700 years. Your ending amount is 0.85. And your starting amount is 1. And we are going to use these numbers in our formula to solve for time. Solve for time. Okay, so time is equal to a negative, what is H? 5,700. Natural log, what is N of T? 0.85. There we go, 0.85. And what is N sub 0? 1. Okay, so it's just 0.85 over 1. Or just 0.85. I just put it over 1 just so you could see where all the numbers go. And then this is divided by the natural log of 2. You're going to take your calculator. You're going to physically type this into your calculator and get an answer. Okay? Make sure you do all parts. Somebody asked, instead of brackets, can you do parentheses? Of course you can. I just do these for aesthetics just because it's easier for me to really kind of read it. Breaks it up a little bit better. And you really want to practice doing this because on the test, if you have to do this, you want to get all those mistakes worked out beforehand because it's very easy to make calculator errors. What did y'all get for your answer rounded to the nearest tenth place? 156.5. Yes, ma'am. So it's going to be over 1,300 years has gone by, has passed for, past. Did I use the right form of past? Or is it P-A-S-S-E-D? Has passed. Is it P-A-S-S-E-D? It is, isn't it? Okay. I was being lazy. I really wanted to make it shorter. Okay. Has passed for 15% to decay. All right, so I want you to look at these numbers to make sure that they make sense. Because if it takes 5,700 years for 50% to decay, it's going to take less than that for only 15% to decay. All right, that's what I'm trying to get you to acknowledge, to kind of see that balance, because it's really difficult to check your work because these numbers are different. They're ugly, they're big, or they're going to be really small, and so you got to be sure that you are comfortable with the information. All right, does anybody have a question over this process right here? Because this is what you're going to be expected to do on a test. Okay, so you'll be given the formula in this form, and then you'll have to manipulate it. Okay, you'll have to manipulate it. All right, no questions? Okay, so here's what I've got some practice problems here for us to practice manipulating. All right, just to get more and more comfortable with the logs and the exponents. All right, take a look at number 4. What would be your first step that you would do on number 4? Divide by 2,000, because our goal is to get t out of the exponent. We've got a base of e, so we're going to have to natural log it, but we can't if we have this coefficient. So divide both sides. That gives you e to the 1/10 t power equals 2. Now, what's your next step? Now you're going to natural log it. So we'll natural log both sides. We've got 0.1 t equals the natural log of 2. What's your next step? There you go. And when we divide the natural log of 2 by 0.1, 0.1 is the same thing as 1/10. Correct? Okay. So technically, this is the natural log of 2 times 10. Do you understand how I did that? Because 1.1 is 1/10. And that means the natural log of 2 is being divided by 1/10. And when we divide with fractions, it's the same thing as multiplying by the reciprocal. So you've got the natural log of 2 times 10. Okay? My goal is to get you comfortable with looking and manipulating these numbers, because you can be getting the right answer, but it's written differently, and you might not realize that this is the same thing as this. Now, you put either one of them in a calculator to get your decimal answer, you're going to get the same result. But I'm going through this more or less as part of like for ACT type questions. If it was multiple choice and you had to pick the right answer, would you know that you can manipulate it into this form? So what do you get when you plug that into the calculator? 6.9. Okay, about 6.9. I'm just going to put 31. Okay, 6.931. All right. I want y'all to look at number 5. How would you approach number 5? Exactly. Folks, this is a proportion. Anytime you have a fraction equaling a whole number or another fraction, that's one ratio set equal to the other. Put that whole number over 1, cross multiply that sucker, get rid of those fractions. Or just remember that you have to undo the division, so you're going to multiply both sides by e to the x plus 2. So what we end up with is 100 e to the x equals 50 times e to the x plus 2. Now, I didn't distribute that 50 because I want to get rid of that 50. What would be my next step that we could do? Divide both sides by 50, exactly. So divide both sides by 50. You've got 2e to the x equals e to the x plus 2. What would y'all do next? Exactly. You can subtract e to the x from 2e to the x. What would you end up with?
2 equals 2.
Ex equals ex minus ex plus
2. It would just be e to the x equals 2. And because your base is the same and your exponent is the same, it's 2 of something and you're taking away 1 of it. So you're left with 1 of it. Okay? But it looks a little foreign because you've got an e and it's to the power of x. But because these are exactly the same, you can add and subtract like terms. And that's all we did was subtract those. Now, how are you going to get x out of the exponent? Natural log. Okay, so we're going to natural log both sides. And what you have is x equals the natural log of 2. Natural log of 2 is
0.7.
okay, 0.7 or 6, I think. It's good. It didn't say what to round to. Okay, now I'm going to go ahead and stop. Let's go ahead and, if I just want to show you. On Monday, I won't be here. And on page 20 and 21, 21 has those problems, the word problems, like what we just did. Okay? But you're going to be working on this, and you're going to be plugging it into Teacher Day to check your answers. All right? So this is Monday. Don't forget, you still have an assignment in TeacherMade that, when is it due? Monday at midnight, okay? And I'll be back on Tuesday, and I'll take up the paper version just to see that work is shown, okay? But I just wanted to go through this. This was